Character Studio also has the ability to create crowd scenes. Now what these scenes consist of is you've got several objects and a set of behaviors, and each object is using the same behaviors, but they're all behaving slightly differently. They're behaving as a crowd. So let's see how that works. The first thing you need for a crowd scene is you need to go to your helpers, and you need a crowd helper and some delegates. Let's make the crowd helper. This is basically a big diamond-shaped object, and you want to make it fairly large. And then you also have delegates. Create one here so you can see it. It's basically a little pyramid-shaped object. And you have a delegate for each object in your scene. So if you wanted to have a crowd of 20 robots or skateboards or people or whatever, you're going to need 20 delegates. And you could just take this first one and make clones of it. So I'm going to go ahead and make a few here, and then a few more clones. So we'll have 7 altogether in the scene. Now we need something for the delegates to do. One of the most common things to have them do is to seek an object in the scene. That gets them all going in a particular direction. So what we'll do is we'll put an object here in the scene. Now they seek the pivot point of the object, so it really doesn't matter how big or detailed the object is. They're going to look for its pivot point. Alright, these are the basic things you need. So let's see how we can set it up so these delegates will seek the sphere. So if we go to the Modify panel, under the delegate here, or rather under the crowd object, on the Modify panel we have all these different options. And what we want to do is set up behaviors. And we want one behavior right now, just one behavior to make them seek the sphere. So under Behaviors we click New, and we're going to set up a seek behavior. These are all the different types of behaviors you can use. Some you'll use more often than others. Seek you're going to use a lot. So we set this up, and we have to tell it what to seek. Click this None button, pick the sphere, then the name sphere shows up here. So now this seek behavior is associated with this crowd helper. Now we need to tell the crowd helper that the behaviors it has need to be affecting these delegates. And we do that with the Behavior Assignments button and the dialog. Big dialog comes up. All your delegates are over here. Now you could individually choose a delegate and a behavior and then assign them with this, and they show up over here. But there's a much easier way. We'll get rid of this association. We haven't gotten rid of the behavior or the delegates. What you can do is you can put all the delegates in something called a team. So over here on the right, we click New Team and pick all our delegates, say OK, and that's Team 0. You can change the name of the team if you like, but anyway, it's a lot easier to just say Team 0, assign the seek behavior, click here, there's the assignment, and you're all set. Now that it's set up, you have to solve the behavior, or solve the scene rather, using the behaviors. So with our crowd delegate selected, scroll down until on the Solve rollout you see the Solve button. Click Solve. Now we will see the delegates seeking the sphere. And when they get there, they just kind of fly around it, swarm around it. So let's see that. Let's look at the top view. The delegates all head for the sphere, and then when they get there, they just kind of swarm around at the sphere. So the scene did work the way we set it up. The delegates did the seek behavior, performed what we asked them to do. So that's basically how you set up a crowd scene. Obviously you're going to want additional behaviors, you're going to want to link objects to the delegates. There's a lot more you can do here, but this is the basic thing. So let's go ahead and save this, and we're going to call it Crowd Basic. So now that we've got our basic crowd scene, let's see how we can improve it. One way is to make it so that when the delegates get to the sphere, they don't all crash into each other and just kind of swarm in this one spot. We're going to make them so they each sort of keep their own space. They don't crash into people. And the way we do that is we add another behavior called avoid. So we click here on New and pick Avoid Behavior. Now what you have to do with the avoid behavior, and as you add each behavior you get a rollout for it. So here on our avoid behavior rollout we can pick which object or objects the delegates are supposed to avoid. Now we want them to avoid each other, so we're going to click multiple selection and pick all the delegates. So we've set this behavior up. Now we need to assign the behavior. So to Team 0 we have an avoid behavior, and that assigns it. So let's take a look at how that looks when it solves. All those lines when it's solving, by the way, are the look ahead. It's looking ahead to make sure that it's not going to, two of them aren't going to end up in the same place shortly. So now they fly over and they try to avoid each other, so they don't all crash into one another. Some of them apparently are going off into space a little bit. They're not going too far away. Hopefully they'd come back eventually. Alright, now let's take a closer look at this avoid behavior. What we've got here is we have something called a hard radius, and this is the area around the delegate into which other delegates will not penetrate. And let's see what the hard radius looks like if we display it. It's basically a circle. When it's set to 1, 1 means it's just the size of the delegate, and you can make it a little bit bigger or smaller. Sometimes it's good to make it a little smaller if they're flying around fast. Give them a little more leeway with one another. So we can solve now. And actually, let's solve a little longer because it's kind of hard to see what's going to happen. They all get there and then they start moving around a little bit. But we can make our animation longer. And also on our solve rollout, we should tell it to end the solving later. Alright. Let's see what it looks like now when we solve. So they're sort of like, I don't know, cells or amoebas or something like that. They're all swarming around. And they stay in the area, but they don't crash into one another. That's pretty much with the default avoid settings. Now one of the things you can do is you can increase this brake pressure. And what that does is that increases the likelihood that a delegate will stop and wait for another one rather than try to go around it. Right now, when they go to avoid each other, for example, this one here is kind of going around, then it pushes through the middle. And if you look at this one, for example, when it wants to get back around, it makes a big detour. And to get away from other ones, this one is taking a big detour as well. It's going all the way around. You could make them more likely to stop rather than go around by increasing the brake pressure. So we select the delegate, rather the crowd helper, and we can increase the brake pressure to, say, 50. And now we can solve and see how that looks. So they're basically a little more polite now. They're more likely to stop rather than just go around. Sort of stopping and waiting for each other to pass. Okay, so that's the avoid behavior. We're going to tack avoid on here. So now that you've got the crowd basics down, we're going to do something a little more sophisticated. what we're going to do is set up in the scene a doorway. So let's put this doorway right about here. And we'll extrude it out a bit. And basically, what we're going to do is try to get the delegates to go through the doorway. Now, how is this going to work? I'm going to think about this for a minute. If you have them seek the sphere, they're going to get here, but then you have to have some way to get them through that door. And the way you can do that is with a wall seek behavior. Now, the way the wall seek works is first you need to set up a grid. So we need a helper, a grid, and we're going to put a grid up right there in the doorway. Move it here so it's right in the door. Then you set up a behavior, a new behavior called wall seek, of course. And it says grid to seek. It has to be a grid. It can't be a plane or some other object. Pick the grid. Now, what you need to do is tell it which direction this force is going to be. Basically, wall seek pulls the delegates toward it in a sort of a hallway in front of the grid. So you can tell it to use a certain distance and that you want to see the distance, and you can see it here. This line shows the distance that's going to be used. Now that's obviously too small. We need to set that much higher, say 120. There we go. Now what we can do is make it so that the delegates will seek the sphere, and then once they get into this area, the behavior that will take over will be the wall seek, and that will pull them up to this point. And then when they get to this point, you could put something else over here for them to seek. For example, we could put another sphere right here. And we want this sphere to be closer than that one. We can actually even move this away just a little bit and move this one a little closer. Alright, so let's take a look at how this is going to work. First of all, I think we need to make that wall seek distance a little bit bigger. There we go. Okay, now we need to set it up so that the wall seek behavior is being used. So let's assign it to the team. Now, here's where we want to get a little tricky. We have this weight parameter here. And what we can do is we can turn down this weight to say 0.8. Now what's going to happen is, since we're using the distance on this wall seek, the delegates aren't going to be affected at all by the wall seek unless they're in this area here. So the only behavior affecting where they're going to go is the seek behavior. The wall seek is not in effect because they're outside of the area. They're over here. So even though the seek behavior only has a weight of 0.8, it's still going to suck them up toward this sphere. Then once they get into this area, the wall seek behavior will take over because it has a bigger weight. It has a weight of 1.0. Let's take a look at that again. Here on our behavior assignments, the wall seek has a higher weight than the seek. So since the wall seek has a higher weight, it's going to pull them up through it. Now, when they get to this point, the wall seek is all finished. They're going to be outside that area, and the seek is going to take over again, and they're going to seek this sphere. And the way that's going to work is if we come here, this is, by the way, how you change behaviors. We pick seek. Instead of having it just look for that one sphere, we can tell it to look for both and to choose the closest target, which is why we have this a little bit further away. In the beginning, this is the closest target and the only influence. They come in here, the wall seek behavior takes over and sucks them through the door, then this sphere is closer at that point, so they seek this sphere. Some of them might end up going back through the door if they have nowhere to go, but hopefully they'll be avoiding the ones coming in and they'll just move into the room or the other side. Well, let's see how it works. They head for the sphere, and they're stuck. They're not going through the door. All right, something's wrong. This is a big part of working with crowds, is troubleshooting. So let's see what the problem could be. One of the problems could be with the wall-seek behavior that the force just isn't strong enough to pull them toward that doorway. So let's see what we've got. Well, first of all, the direction it's working on is the positive axis. Let's make sure that that's correct. The way you check that is you choose your grid and turn on the local coordinate system and look at which way the Z is pointing. And so the Z is pointing straight out. That's our positive axis, so that is working correctly. The next thing is it's only using distance, and there's a certain fall off. And we have end force at grid edges. Maybe if we turn this off, it will be a more global force, and it will have an influence on these delegates while it's outside the wall seek. Let's see how well that works. So they head for the sphere, and they're all getting stuck. Okay, that's not helping. By the way, you can press escape and stop the recording anytime. Stop the solving anytime. So let's try turning down the influence of the seek behavior. Let's go with something really small, like 0.1. Better to try for an extreme. And I do want to end the force at the grid edges. So they're heading for the sphere, and as soon as they get in there, oh, they're heading for the doorway. It's going a little better now. Now some of them are heading back through. Not necessarily working as well as it could, but at least we got them through the doorway. So there you have it. They're heading through. Now, one of the problems we have is that they're going, some of them are going on the outside edge of the doorway. The reason being that it's looking at the pivot point at the center of the delegate, and if the pivot point is going through the edge of the grid, it still thinks it's okay. So what we need to do to fix that is we need to make the grid less wide. Let's see what happens now. Well, they're still passing through the wall and coming back again. So let's see how we can fix this and make it better. So they're coming up here. One is going through, one's going through the wall. Let's see if we turn off end force at grid edges, if it's better. Oh, we still got them going through the walls all over the place. Well, they are going through in the beginning okay. This one's passing through the wall, but I think we can fix that. The rest of them are going through fine. Now, if you have a situation like this where everybody's going through the hallway correctly, except this one guy, a lot of times you can just delete it after you do your solution. If you delete it and then you solve again, you might have a different configuration because of them avoiding each other differently. So I usually make about 10% more delegates than I really need. Now, one of the problems you have is that when they're coming through this doorway, after they come in here, they're coming back around and going through the wall, and that's not good. So there's a couple things we can do to fix this up. Let's take a look at what they are, but in the meantime, let's save this. We'll call it doorway. One of the most powerful tools you can use when you're doing a crowd simulation is vector fields. The way that works is, well, I'll just show it to you. First thing I'm going to do is create a capsule. Capsules work really, really well with vector fields. It's my object of choice for this kind of thing. So I'm going to create a capsule here around the wall. Now you might think this looks a little strange, and we're not going to be rendering it. And then, well, we'll just start out with one. Then we can make a copy of it. Now, we have to create a space warp, a vector field space warp. And you'll find that under space warps, under particles and dynamics. There it is, a vector field. Now what you do with this is you create a big box around the object that you're using for your vector field. This creates what's called a lattice. It starts to clutter up the screen a bit, but it will be worth it in the end. Now we need lots of segments on this. I usually do 10 by 10 by 10. And here you're telling it to show the lattice. We can turn that off if you don't want to look at it anymore because it's kind of hard to see what's going on. But basically this creates a grid for the creation of your vector field. The vectors sticking out from your object are going to be what tell the delegates what direction to go in. So when they come in contact with it, it's like having little hairs sticking out of it that kind of make things flow in a certain direction. So we can turn off the lattice. Now we need to create a range around this object. And the way we do that is down here we have a range. First we need to pick the vector field object under Compute Vectors. And again, we have the vector field selected and we're on the Modify panel. So we pick our object, we've got our capsule, and now we have to create a range around the capsule. So we increase this range parameter, and you can see around the original capsule there's this bigger capsule. This area between the inner capsule and the outer one is where the vector field is going to be created. Now it also has to be inside the lattice. That's why we make the lattice so big. So we have plenty of room in here for our vector field. So the range is outside the object and the lattice needs to be outside the range. Alright, now we're ready to compute the vector field and see how it looks. So we click Compute. And supposedly did it, but it's kind of hard to see. We say Show Vector Field, and we've got these blue dots. If we increase the vector scale, this is going to show us, there it is. And you can see that here. It's all these sort of prickly lines, whoops, sticking out. Now what's going to happen here is when a delegate comes into this area, it's going to be forced to move perpendicular to the lines. So if it gets close to the wall, it's going to be forced either toward the door or away from the door. And if it's forced toward the door, it's going to be sort of pulled around through the door and into the other room. That's what the vector field is going to do. So let's see how well that works. We select our crowd helper, and we need to add a new behavior here called space warp. And basically, the vector field is the only space warp that works with this. So we click here and pick our vector field object, vector field 1. Now let's click Solve. Oh, we didn't assign the behavior. Oops. Space warp. There we go. Alright, now we'll solve. Okay, so the delegates are coming up and they're getting pushed around the vector field, and see a couple of them are getting pulled around this way. One of them's stuck. He's in there. A couple of them are. Alright, so the vector field is pulling them through the doorway and keeping them away from the walls. So we still have one going through the wall over here, but if we take our object and our vector field, let's select the capsule and the vector field, and let's clone those over here. We've still got local on. There we go. Clone them right over here and set up a new behavior, another space warp behavior, and it's going to name it space warp 1. This is our new one here, and assign that one as well. Now let's solve again and see what happens. Well, let me see something. With this space warp, I need to select this and recompute it. There we go. So it wasn't really having an effect on the scene until I recomputed it. So now they're all being forced through the door and forced around. Now what you could do, if you wanted them to all stay in that room, let's just take a look at what they're doing and then we'll figure out how we can fix it. So see, this guy is being forced through the door now because of the vector field. So the key here is to make the vector field in the shape of what you want the delegates to do. For example, you could put another vector field out here on top of this one or near it to make the delegates flow over in this direction or go someplace else. But basically we have them at least going through our narrow little doorway and then going out. So let's save this. And I'm going to add a VF here for vector field. So let's take a look at how this scene looks without all the stuff in it that we've got in here. We've got a grid, we've got spheres, we've got these giant capsules, and you can hide all those things and the scene will still solve, the simulation will still solve. So let's hide everything except the delegates and the crowd helper. And actually, I would like to see the wall, which is called rectangle. For the wall seek, I believe that's the distance that's showing up there. So let's pick the wall seek and turn off display distance. There we go, so we don't have to look at that thing anymore. Okay, let's see what the delegates are doing. They're going through the doorway. Now we could just stop the animation here at frame 140. Why don't we do that? Just because it looks pretty good up to that point. So the delegates are going through the door. Now, of course, once you get your scene done, your simulation done, let's assume this is all you wanted to do. Now you want to put your objects where the delegates are. You want to link your objects to the delegates, and there's an easy way to do that. What I've got here is I've got a series of objects called robot 1 through 7, and these are basically little tiny, sort of robot-shaped things, shaped like R2-D2. And you could manually just align each of these with one of the delegates and link them together. But there's an automatic way to do that makes it really easy. Select the crowd helper. And we come here to Object delegate associations. And over here you pick your objects, which is robots. And here you pick your delegates. Get your 7 delegates. And if you click Align Objects with Delegates, watch here. Bang, there they are. They're aligned. They're actually aligned the wrong end, though. But that's okay. What you want to do is make sure the pivot point lines up with the delegate's pivot point before you do this. It's okay for what we've got here, but I would have preferred it at the bottom. Then you can say Link Objects to Delegates, and it just goes ahead and links all of them, and then you're done. So now you could take the delegates and the crowd helper and hide them. And this is what you end up rendering. So you see the scene gets pretty messy sometimes, but in the end you just hide everything you don't want and you've got a nice clean scene. So let's save this. Oops. So our basic scene is done. So I'm going to call this one done.